In the last chapter, you learned about motherboards. In this chapter, you'll learn about the two most important components on the motherboard, which are the processor and memory. You'll learn how a processor works, about the many different types and brands of processors, and how to match a processor to the motherboard. Memory technologies have evolved over the years. When you support an assortment of desktop and notebook computers, you'll be amazed at all the different variations of memory modules used in newer computers and older computers still in use. A simple problem of replacing a bad memory module can become a complex research project if you don't have a good grasp of current and past memory technologies. The processor and memory modules are considered Field Replaceable Units, FRU, so you'll learn how to install and upgrade a processor and memory modules. Upgrading the processor or adding more memory to a system can sometimes greatly improve performance. How to troubleshoot problems with a processor or memory is covered in Chapter 13, Troubleshooting Hardware Problems. Types and characteristics of processors. The processor installed on a motherboard is the primary component that determines the computing power of the system. Recall that the two major manufacturers of processors are Intel, www.intel.com, and AMD, www.amd.com. An AMD Athlon 64X2 installed in socket AM2 Plus with cooler not yet installed. Copyright Cengage Learning 2014. In this chapter, you learn a lot of details about processors. As you do, try to keep these 9 features of processors at the forefront. These features affect performance and compatibility with motherboards. Feature 1, Clock speed. The processor supports. Current Intel and AMD processors work with system buses that run at 1.8 GHz up to more than 3.4 GHz. Recall from Chapter 4 that the smaller the processor multiplier, the faster the system bus runs in comparison to the processor speed. Feature 2, Processor speed. The processor core frequency is measured in gigahertz, such as 3.3 GHz. Socket and chipset the processor can use. Recall from Chapter 4 that important Intel sockets for desktop systems are the PGA 988, LGA 2011, LGA 1155, LGA 1156, LGA 1366, and LGA 775. AMD's important desktop sockets are AM3+, AM3, AM2+, AM2, FM1, F, and 940 sockets. Feature 4, Processor architecture, 32 bits or 64 bits. All desktop and laptop processors sold today from either Intel or AMD are hybrid processors, which can process 64 bits or 32 bits at a time, but older processors handled only 32 bits. A hybrid processor can use a 32-bit operating system or a 64-bit OS. Most editions of Windows 7 come in either type. Feature 5, Multiprocessing abilities. The ability of a system to do more than one thing at a time is accomplished by several means. Multiprocessing. 2 processing units, called arithmetic logic units or ALUs, installed within a single processor, called multiprocessing and first used by Pentium processors. The Pentium was the first processor that could execute 2 instructions at the same time. Dual processors. A server motherboard might have 2 processor sockets, called dual processors or a multiprocessor platform, see Figure 5.2. A processor, for example, the Xeon processor for servers, must support this feature. Multi-core processing. Multiple processors can be installed in the same processor housing, called multi-core processing. A processor package might contain up to 8 cores, dual core, triple core, quad core, and so forth. Multi-threading. Each processor or core processes 2 threads at the same time. When Windows hands off a task to the CPU, it is called a thread and might involve several instructions. To handle 2 threads, the processor requires extra registers, or holding areas, within the processor housing that it uses to switch between threads. In effect, you have 2 logical processors for each physical processor or core. Intel calls this technology hyper-threading and AMD calls it hyper-transport. The feature must be enabled in BIOS setup. Feature 6, Memory Cache, which is the amount of memory included within the processor package. Today's processors all have some memory on the processor chip, called a die. Memory on the processor die is called Level 1 cache, L1 cache. Memory in the processor package, but not on the processor die, is called Level 2 cache, L2 cache. Some processors use a third cache farther from the processor core, but still in the processor package, which is called Level 3 cache, L3 cache. Memory used in a memory cache. 228.1.6 is static RAM or SRAM, pronounced SRAM. Memory used on the motherboard loses data rapidly and must be refreshed often. It is, therefore, called volatile memory or dynamic RAM or DRAM, pronounced DRAM. SRAM is faster than DRAM because it doesn't need refreshing, it can hold its data as long as power is available. Feature 7, the memory features on the motherboard that the processor can support. Current types of DRAM memory modules used on a motherboard include DDR, DDR2, or DDR3. Besides the type of memory, a processor can support certain amounts of memory speeds, and number of memory channels, single, dual, triple, or quad channels. All these characteristics of memory are discussed later in the chapter. Feature 8, support for virtualization. Recall from Chapter 4 that a computer can use software to create and manage multiple virtual machines that contain virtual devices. Most processors sold today support virtualization, and the feature must be enabled in BIOS setup. Feature 9, integrated graphics. A processor might include an integrated GPU. A graphics processing unit, GPU, is a processor that manipulates graphics data to form the images on a monitor screen. The GPU might be on a video card, on the motherboard, or embedded in the CPU package. When inside the CPU package, it is called integrated graphics. Many AMD processors and all the Intel 2nd generation, Sandy Bridge, and 3rd generation, Ivy Bridge, processors have integrated graphics. How a processor works. Although processors continue to evolve, they all have some common elements. These elements are diagrammed in Figure 5.3 for the Pentium processor. The Pentium made several major advances in processor technologies when it was first introduced. Because of its historical significance and the foundation it created for today's processors, it's a great place to start when learning how a processor works. A processor contains these basic components diagrammed in Figure 5.3 for the Pentium processor. An input, output, I/O unit manages data and instructions entering and leaving the processor. A control unit manages all activities inside the processor itself. One or more arithmetic logic units, ALUs, do all logical comparisons and calculations inside the processor. All desktop and laptop processors sold today contain 2 ALUs in each processor core within the processor package. Registers, which are small holding areas on the processor chip, work much like RAM does outside the processor to hold counters, data, instructions, and addresses that the ALU is currently processing. Internal memory caches, L1, L2, and possibly L3, hold data and instructions waiting to be processed by the ALU. Buses inside the processor connect components within the processor housing. These buses run at a much higher frequency than the front side bus, FSB, that connects the processor to the chipset and memory on the motherboard. The speed at which the processor operates internally is called the processor frequency. For example, if the processor operates at 3.2 GHz internally but the front side bus is operating at 800 MHz, the processor operates at 4 times the FSB speed. This factor is called the multiplier. As you learned in Chapter 4, you can view the actual processor frequency and the clock speed using the BIOS setup screens. You can also change the multiplier or the clock speed in order to overclock or throttle the processor. In Figure 5.3, you can see the internal data bus for the Pentium was only 32 bits wide. More important, however, and the width of the internal bus is the fact that each All-in register in the early Pentiums could process only 32 bits at a time. All desktop and laptop processors sold today from either Intel or AMD contain ALUs and registers that can process 32 bits or 64 bits at a time. To know which type of operating system to install, you need to be aware of 3 categories of processors currently used on desktop and laptop computers. 32-bit processors. These older processors are known as x86 processors because Intel used the number 86 in the model number of these processors. If you are ever called on to install Windows on one of these old Pentium computers, you must use a 32-bit version of Windows. These processors can handle only 32-bit instructions from the OS. Processors that can process 32 bits or 64 bits. These hybrid processors are known as x86 64-bit processors. AMD was the first to produce one, the Athlon 64, and called the technology AMD 64. Intel followed with a version of its Pentium 4 processors and called the technology Extended Memory 64 Technology, EM64T. Because of their hybrid nature, these processors can handle 32-bit OS or a 64-bit OS. All desktop or laptop processors made after 2007 are of this type. 64-bit processors. Intel makes several 64-bit processors for workstations or servers that usefully implemented 64-bit processing, including the Itanium and Xeon processors. Intel calls the technology IA64, but they are also called x64 processors. They require a 64-bit operating system and can handle 32-bit applications only by simulating 32-bit processing. Each core in a processor has its own cache and can also share cache. Figure 5.4 shows how quad-core processing can work if the processor uses an L3 cache and an internal memory controller. Each core within a processor has its own independent internal L1 and L2 caches. The L1 cache is on the die and the L2 cache is off the die. In addition, all the cores must share an L3 cache within the processor package. Recall from Chapter 4 that prior to the memory controller being in the processor package, it was part of the Northbridge chipset. Putting the controller inside the processor package resulted in a significant increase in system performance. Intel processors. Intel's current families of processors for the desktop include the Core, Atom, Celeron, and Pentium families of processors. In addition, Intel groups its processors into 3rd generation, 2nd generation, and previous generation processors. Each generation improves on how the processor and chipset are integrated into the system. Processors in each family are listed in Table 5.1. Some significant retired processors are also listed. Later in the chapter, I'll explain the memory technologies mentioned in the table. Some of the Intel mobile processors are packaged in the Centrino processor technology. Using the Centrino technology, the Intel processor, chipset, and wireless network adapter are all interconnected as a unit, which improves laptop performance. Several Intel mobile processors have been packaged as a Centrino processor. You also need to be aware of the Intel Atom processor, which is Intel's smallest processor and is used in low-cost PCs, laptops, and notebooks. AMD processors. Processors by Advanced Micro Devices Incorporated or AMD, www.amd.com, are popular in the game and hobbyist markets and are generally less expensive than comparable Intel processors. Recall that AMD processors use different sockets than do Intel processors, so the motherboard must be designed for one manufacturer's processor or the other, but not both. Many motherboard manufacturers offer 2 comparable motherboards, one for an Intel processor and one for an AMD processor. The current AMD processor families are the FX, Phenom, Athlon, and Symphony for desktops and the Athlon, Turion, V-Series, Phenom, and Symphony for laptops. Table 5.2 lists the current AMD processors for desktops. Figure 5.7 shows an FX processor by AMD. Selecting and installing a processor. A PC repair technician is sometimes called on to assemble a PC from parts, exchange a processor that is faulty, add a second processor to a dual processor system, or upgrade an existing processor to improve performance. In each situation, it is necessary to know how to match a processor for the system in which it is installed. And then you need to know how to install the processor on the motherboard for each of the current Intel and AMD sockets used for desktop and laptop systems. In this part of the chapter, you'll learn about selecting and installing processors in desktops. In Chapter 19, you'll learn about selecting and installing processors in laptops. Select a processor to match system needs. When selecting a processor, the first requirement is to select one that the motherboard is designed to support. Among the processors the board supports, you need to select the best one that meets the general requirements of the system and the user's needs. To get the best performance, use the highest performing processor the board supports. However, sometimes you need to sacrifice performance for cost. When building a new system, if the motherboard is not already installed in the case, follow the directions of the motherboard manufacturer to install the motherboard and then the processor, or to install the processor and then the motherboard. The order of installation varies among manufacturers. When replacing a processor in an existing system, power down the system, unplug the power cord, press the power button to drain the system of power and open the case. Follow these steps to install the processor and cooler using socket LGA 1155. 1. Read all directions in the motherboard user guide and carefully follow them in order. 2. Use a ground bracelet or anti-static gloves to protect the processor, motherboard, and other components against ESD. 3. Open the socket by pushing down on the socket lever and gently pushing it away from the socket to lift the lever. 5. Remove the socket protective cover, see Figure 511. Keep this cover in a safe place. If you ever remove the processor, put the cover back in the socket to protect the socket. While the socket is exposed, be very careful to not touch the pins in the socket. 6. Remove the protective cover from the processor. You can see the processor in this clear plastic cover on the right side of Figure 512, which also shows the open socket. While the processor contacts are exposed, take extreme care to not touch the bottom of the processor. Hold it only at its edges. It's best to use anti-static gloves as you work, but the gloves make it difficult to handle the processor. Put the processor cover in a safe place and use it to protect the processor if you ever remove the processor from the socket. 7. Hold the processor with your index finger and thumb and orient the processor so that the gold triangle on the corner of the processor lines up with the right angle mark embedded on the motherboard just outside a corner of the socket, see Figure 513. Gently lower the processor straight down into the socket. Don't allow the processor to tilt, slide, or shift as you put it in the socket. To protect the pads, it needs to go straight down into the socket. 8. Check carefully to make sure the processor is aligned correctly in the socket. Closing the socket without the processor fully seated can destroy the socket. Figure 514 shows the processor fully seated in the socket. Close the socket load plate so that it catches under the screw head at the front of the socket. 9. Push down on the lever and gently return it to its locked position, see Figure 516. We are now ready to install the cooler. Before installing a cooler, read the directions carefully and make sure you understand them. Clips that hold the fan and heat sink to the processor frame or housing are sometimes difficult to install. The directions might give you important tips. Follow these general steps. 1. The motherboard has 4 holes to anchor the cooler. You can see them labeled in Figure 517. Examine the cooler posts that fit over these holes and the clips, screws, or wires that will hold the cooler firmly in place. Make sure you understand how this mechanism works. 2. If the cooler has thermal compound pre-applied, remove the plastic from the compound. If the cooler does not have thermal compound applied, put a small dot of compound, about the size of a small pea, in the center of the processor, see Figure 517. When the cooler is attached and the processor is running, the compound spreads over the surface. Don't use too much, just enough to later create a thin layer. If you use too much compound, it can slide off the housing and damage the processor or circuits on the motherboard. To get just the right amount, you can buy individual packets that each contain a single application of the thermal compound. 3. Verify the locking pins on the cooler are turned as far as they will go in a counterclockwise direction. Make sure the pins don't protrude into the hollow plastic posts that go down into the motherboard holes. Align the cooler over the processor so that all 4 posts fit into the 4 holes on the motherboard and the fan power cord can reach the fan header on the motherboard. 4. Push down on each locking pin until you hear it pop into the hole, see Figure 519. To help keep the cooler balanced and in position, push down 2 opposite pins and then push the remaining 2 pins in place. Using a FLO head screwdriver, turn the locking pin clockwise to secure it. Later, if you need to remove the cooler, turn each locking pin counterclockwise to release it from the hole. After the processor and cooler are installed and the motherboard is installed in the case, make sure cables and cords don't obstruct fans or airflow, especially airflow around the processor and video card. Use cable ties to tie cords and cables up and out of the way. Make one last check to verify all power connectors are in place and other cords and cables connected to the motherboard are correctly done. You are now ready to plug back up the system, turn it on, and verify all is working. If the power comes on, you hear the fan spinning and see lights, but the system fails to work. Most likely the processor is not seated solidly in the socket or some power cord has not yet been connected or is not solidly connected. Turn everything off, unplug the power cord, press the power button to drain power, open the case, and recheck your installation. If the system comes up and begins the boot process, but suddenly turns off before the boot is complete, most likely the processor is overheating because the cooler is not installed correctly. Turn everything off. Unplug the power cord, press the power button to drain power, open the case, and verify the cooler is securely seated and connected. After the system is up and running, you can check BIOS setup to verify that the system recognized the processor correctly. The setup screen for one processor is shown in Figure 521. Look for items on the screen that manage processor features, and make sure each is set correctly. For example, in Figure 521, items listed in blue can be changed. Verify the 2 blue items that apply to the processor, verify that all processor cores are active and hyper-threading technology is enabled. If you see the processor temperature rising and reaching 80 degrees, open the case cover and verify the processor fan is running. Perhaps a wire is in the way and preventing the fan from turning or the fan wire is not connected. Other troubleshooting tips for processors are covered in Chapter 13. Installing an Intel processor in socket LGA 1366. The installations of all processors and sockets in this part of the chapter are similar to that of installing a processor in socket LGA 1155, so we will not repeat many of those steps. Listed next are the differences when installing a processor in the LGA 1366 socket. These socket pins are delicate, so work slowly and take care. Here is how to work with this socket. 1. To open the socket, press down on the socket lever and gently push it away from the socket to lift the lever, see Figure 523. You can then lift the socket load plate, as shown in Figure 524. Next, remove the socket protective cover. 2. To install the processor, hold the processor with your index finger and thumb and orient the processor so that the notches on the 2 edges of the processor line up with the 2 posts on the socket. You can see the notch and post on the right side of the processor and socket in Figure 525. Gently lower the processor straight down into the socket. Don't allow the processor to tilt, slide, or shift as you put it in the socket. To protect the pins, it needs to go straight down into the socket. Installing an Intel processor in socket LGA 775. Socket LGA 775 is shown in Figure 527 along with a Pentium processor and cooler. In the photo, the socket is open and the protective cover removed. The processor is lying upside down in front of the cooler. When installing a processor in socket LGA775, do the following. 1. Push down on the lever and gently push it away from the socket to lift it. Lift the socket load plate. Remove the socket protective cover. 2. Orient the processor so that the notches on the two edges of the processor line up with the two notches on the socket, see Figure 529. Gently place the processor in the socket. Socket LGA775 doesn't have those delicate pins that socket LGA1366 has, but you still need to be careful to not touch the top of the socket or the bottom of the processor as you work. 3. Close the socket cover. Push down on the lever and gently return it to its locked position. Installing an AMD processor in socket AM2 Plus. When installing an AMD processor in AMD socket AM2, AM2 Plus, or other AMD sockets, do the following. 1. Open the socket lever. If there's a protective cover over the socket, remove it. 2. Holding the processor very carefully so you don't touch the bottom, orient the 4 empty positions on the bottom with the 4 empty positions in the socket, see Figure 530. For some AMD sockets, a gold triangle on one corner of the processor matches up with a small triangle on a corner of the socket. Carefully lower the processor into the socket. Don't allow it to tilt or slide as it goes into the socket. The pins on the bottom of the processor are very delicate, so take care as you work. 3. Check carefully to make sure the pins in the processor are sitting slightly into the holes. Make sure the pins are not offset from the holes. If you try to use the lever to put pressure on these pins and they are not aligned correctly, you can destroy the processor. You can actually feel the pins settle into place when you're lowering the processor into the socket correctly. 4. Press the lever down and gently into position. Figure 531. Lower the lever into place, which puts pressure on the processor. 5. You are now ready to apply the thermal compound and install the cooler assembly. For one system, the black retention mechanism for the cooler is already installed on the motherboard, see Figure 532. Sit the cooler on top of the processor, aligning it inside the retention mechanism. 6. Next, clip into place the clipping mechanism on one side of the cooler. Then push down firmly on the clip on the opposite side of the cooler assembly, the clip will snap into place. Figure 533 shows the clip on one side in place for a system that has a yellow retention mechanism and a black cooler clip. Later, if you need to remove the cooler, use a Phillips screwdriver to remove the screws holding the retention mechanism in place. Then remove the retention mechanism along with the entire cooler assembly. That will be all for this video, so be sure to hit that like button and subscribe to CTech and enable that bell icon so you don't miss any further videos with us.